today's lecture. This lecture we would be studying about half subtractor and full subtractor operation. Just like in the previous class, we did studied some of the full adder and half adder operations, and this time this is different. We would be studying about half subtractor and full subtractor operation. Now, same as in the case of half adder operation, we have two input and the difference, and here in case of carry we have a borrow here. Okay, so for each case we would be having a difference output and also a borrow output. Now by looking at the expression, we can also use KMF for that, but by looking at the expression we can say that the difference would be XOR operation. It is same as that of addition operation, whereas for borrow operation we have difference here. This is X dash Y. Okay, only the single mean term, respective mean term. So this is your half subtractor operation, and you can use these two expressions to implement the half subtraction operation. Okay, now full subtractor operation, this one is a little bit complicated. We have 3 bits X, Y and Z. Before going into this expression, just consider here a simple expression. This would be nomenclature used for that particular truth table. We have A of I is your first number, B of I is your second number, and you have to find out the difference between these two. And we assume that A of I is greater than B of I. Okay, we assume that such that the answer is a positive number. Okay. Now you see, in each case we would be having a borrow that would be represented by small letter B0, B of I. Okay, we're going to consider this as B of I. Okay, now for first case there might be a borrow. Okay, for the first case there might be a borrow. Just in the case of addition operation, the carry C0 was always 0. Okay, we can say that C0 is always 0. But in this case, we cannot say that B0 is always 0. Okay, if suppose this is the case and we have to find the subtraction, then you see we cannot find the subtraction 0 minus 1. We have to take on the borrow from here, this side. Okay, so by taking on borrow, we have 10 here and 10 minus 1, that is 1. Okay, but there is a borrow that would be represented here. Okay, a borrow of each stage is represented upon this stage. Okay, so this is how the calculation is done, and we have a difference d0, d1, d2 and d3. Okay, now you see d0, or we can say on each case we would be considering the very first case. Okay, let's consider the very first case. D0, you see B0 minus A0. Okay, this is the first operation you do. If this is the first operation you do. In case of addition, we did this as the first operation, but in case of subtraction we would be doing this as the first operation. Now B0 minus A0, the answer we getting whatever answer we get from that minus B0, that would be your final answer. So thereby we can say that the simplified expression would be something like this. Whereas the borrow, that is B1, you see the borrow output from this particular stage is B1, and that would be represented here. Okay, the borrow output from that particular stage. Okay, if we need a borrow from this stage, that would be represented on the next stage. Okay, that will represent that this particular stage has borrowed 1 from this particular stage. Thereby there would be a deficiency of 1 there. Okay, I will make you understand with an example. Okay, this is just to get you started with the concept. So we have a full subtractor, we have A0, B0 and small b0. Okay, and depending on that we have a difference and also have a borrow here. Okay, by looking at the K map we can also say that the difference being this one and the borrow being this one. Okay, so let's consider this particular operation. Okay, this would be your first operation to understand. Okay, let's just understand this particular iteration. We have A of I as 0, B of I as 1. Just consider here This is not 0, this is actually I. Okay, let's rectify this one. These are I. So for this particular iteration, we have a of I as 0, b of I as 1, whereas small b of I as 1. Okay. Now, if you want to calculate the difference of these two, you see we have 0, or this stage says that we have a borrow. Okay, one borrow is been requested by the previous stages. So we can say that here 1 was taken, but as there is 0, we cannot take 1 from there. So 1 should be taken from its previous stages. Okay, so if 1 is taken from its previous stages, we can say that this stage exhibits a borrow, which would be transferred to the next bit, that is b of I plus of 1. Okay, now what about this bit calculation? As 1 was taken as a borrow from its previous stages, so there is no 0, there would be 10. But as its next stage, its previous stage has requested a borrow from 10, so 1 would be transferred to that, and here remains not 0, here remains 1. So 1 minus 1, there goes 0. So that is the difference. But as a carry was requested, 1 would be a carry for this stage, which would be transferred to the previous stage, which will tell us that a carry was requested by this particular stage. Okay, the very same thing, we take another example here. 0 is borrow for this particular iteration, the second iteration, and it says that there is no borrow taken, so 1 is there. Okay, we have to calculate this first. Okay, in each case we have to calculate this first. Okay, so as 0 is not taken from here, so 1 remains there. 1 minus 1, that is 0. Now to calculate 1 minus 1, we don't need a borrow, so that's why the borrow output of this particular stage is going to be 0. Okay, I will do an example here. We have to calculate the difference of these two. The first one is 11, second one is 4, so the answer should be 7. Okay, so 1 minus 0, that is 1. Okay, there is no borrow. Okay, so for that we can say that there is no borrow, that is 0. And for previous stage, obviously, to calculate 1 minus 0, we also don't need any borrow. Okay, so 1 minus 0, again there is 1, and there is no borrow needed, that is 0. 0 minus 1, that is we need a borrow from here, so we're going to say that we have taken borrow here 1. Now borrow was taken to here, 1 from 0, 1 from here goes to this, there goes to 10. Now 10 minus 1, that is 1. Okay, now what remains here, as we have taken 1 as a borrow, so 1 minus 1, that remains 0, so there goes 0. Now this goes to 7. Okay, this goes to 7. So this is your final answer.